Hi everyone, my name is Pavel Šnaider and I'm here to talk to you today about how Docker didn't invent containers. So rough structure of my talk is I'm going to compare containers to hypervisors. Then I'm going to walk you through the history of container technologies, and that's going to evolve primarily around OpenVZ. And I'm going to touch how containers ended up in vanilla kernel, which is what Docker uses in the end. I'm going to sort through some tools, how to manage containers in vanilla kernel, and how Docker fits into that picture, and then there are some conclusions by the end of the talk. So who am I? I'm a co-founder of VPS3CZ, which is a community-run virtual server provider. Unlike commercial providers, we try to be helpful to each other. Our operations are fully transparent, so you can see everything from what we run on the servers to how we manage our money. Everything is transparent. I've been doing the startups a bit. I was CTO of a small startup, Railbit, which provided a solution how to cluster PHP applications using containers seamlessly on like half of your data center. But that wasn't really commercially successful, so we closed it. To give you a hint of my experience with containers, I've been working with containers since 2009 in production. So that's way before Docker even appeared on the scene. So hypervisors. When you're using hypervisor virtualization, which is Xen, KVM, Hyper-V, and all the likes, you're basically spawning up whole operating system, whole virtual machine every time you spawn a VM. That means you, in the end, if you run Linux mostly environment, then in the end on a single hardware you have multiple kernels. They don't share resources that efficiently because there's hypervisor in charge of managing those resources. If you need some more memory, you need to ask the virtual machine, and that virtual machine has to have drivers for things like ballooning and stuff. So full virtual machines don't give up resources that easily. They don't like to do that. So it's harder to put as many virtual machines as containers on the same hardware. It's also unnecessary overhead to run many kernels when you only need to run Linux on that hardware. So in direct contrast to that are operating system level containers, which is basically where we run just one kernel on the physical hardware, and then you run init and all the user space utilities separated from each other, that they can't see each other, and they think they are running on a separate hardware machine, but they are not. The kernel divides the resources and creates the barriers so the processes don't see each other. Of course, containers are more flexible than hypervisors, so you can do much more interesting stuff with containers. You can even containerize applications alone. That means you will have only single kernel running, and you don't have to run init and all the user space tools like SSH and all that in that container. You only need to run your application, basically. So if you want to save resources even more, just start up the application directly in the container, and you don't have to run all of the other stuff that's there. And you can take this concept even further and share even the libraries. So if you have a shared file system between the containers, and it's all on a single file system, the kernel will share the memory for libraries as well. So, where do containers come from as a technology? Unlike the hypervisors, which are used mainly in the enterprise, containers have their origins in web hosting business, because web hosters always like to cram as much customers as they can on a single hardware node, because that's where their money is basically. They don't sell the computing power alone as such. They make money on the hardware over provisioning side of things, and that's much easier done with containers. So in '98, FreeBSD 4.0 came out with what I would call first container technology for real use. That is the technology that's called jails, and it's still available in FreeBSD today, and it's much more advanced by now. So if you are looking for containers and you're not especially hung up on Linux, you can use FreeBSD to do container virtualization right now. Unlike the other options, jails up to this day don't have that many options when it comes to limiting resources of the containers. So next big step in the container game is SWSoft company. They were founded in, I think it was 1998, but they were in stealth mode for a long time. It's originally a Russian company, so they take the correct Russian approach to solving problems. You will see later on in the talk. So they started with a simple idea that the processes could be grouped together with namespace isolation, which in the end enforces the processes not to see each other. They needed to share the code and save memory thanks to the shared libraries in memory. Basically, that's what they wanted to do, and they wanted very flexible resource management. Unlike fully virtualized virtual machines, when you need to add 1 gig memory, you can do that in an instant with the container. And when you need to take away 1 gig memory from the container, it's also an instant operation if that container is not using the memory. If it is, then some processes will be killed, but the memory will be freed in the end. Later on, SWSoft merged with Parallels, so you will know the guys today under the umbrella company named Parallels. Also in 2001, Linux vServer project appeared, which enabled you to do operating system level containers as early as in 2001, but it's poorly maintained and it's mostly one-man show. So it is possible to deploy Linux vServer today, but it's not as good as the other options. In 2004, Sun releases their operating system Solaris with new technology called zones. It's the container technology for Solaris. Actually, Sun coined the term containers. They were the first to use the term. Also in 2004, SWSoft releases Virtuoso for Windows, which is a crazy hack for Windows kernel, and it enabled you to do containers on Windows as early as on Windows XP. Some kernel developers from Microsoft say that Virtuoso is by far the most advanced software for Windows ever written, because it patches the kernel really in a really crazy way, and they basically have done it without even talking to Microsoft. In 2005, OpenVZ project is released. That is what is Virtuoso. What was Virtuoso? That was closed source even for Linux. So in 2005, the guys from SWSoft decided to open source that stuff and create a community around it. And they set the goal to upstream the container technologies, so they would end up in vanilla kernel, because by that year it was all just a huge patch against the vanilla kernel. It wasn't upstream. So main components of OpenVZ projects are namespaces, which isolate the processes on many different levels, so they don't see each other. So they have different PIDs, process IDs. They see different mounts. They see different machine hostname, and they can have different IP addresses and different networking stacks. And of course, inter-process communications are separated out as well. User bean counters mechanism, UBC, is what they use for resources management. Basically, it's a really sophisticated mechanism how to limit processes and what they can do on the system. So they can limit number of CPU cores, the exact amount of CPU time that the process can actually use. And they count memory in many different ways. So it counts memory which the process uses itself, which is called user memory, but it even counts the kernel memory, which is used by the kernel on behalf of processes in the container. So if the container, for example, opens a socket and wants to talk to someone over the network, there's a buffer associated with that socket, and that's a kernel memory, and user bean counters tracks that. Current Linux containers in upstream don't track kernel memory, so that's why I'm saying that. The other important component is VZ quota. So when you put multiple operating system level containers on a single shared file system, you need some way to limit the disk space that the container can use, but it's just a directory. So how do you do that? They added a layer, basically, which is called VZ quota, and it counts all the data, all the number of files that the container uses, and enforces the limits on that. And VZCTL is the user space component to control the operating system level containers, so you can spawn them really quickly, you can change the resources, you can manipulate the container in every thinkable way really easily. And OpenVZ project is alive to this very day, and still development is still ongoing. Basically, OpenVZ project is like the feature upstream for what we have in current upstream kernels. They are the ones who develop it, and when they decided in 2005 that they would upstream the technologies, they basically found out that they would have to re-implement most of the stuff. So what they managed to get in the kernel is a bit different from OpenVZ itself, but they are trying to do that in a really consistent way that you don't lose features which you have with OpenVZ when using upstream kernel. In 2006, OpenVZ adds an interesting feature, which is live migration. That is a really crazy feature when you think about it. When you think about running process on a Linux machine, and you want to get that process on a different machine somewhere else, it's not really that easy to do that. You need to kind of grab all of the information, all of the state that the process managed to create during its lifetime, and somehow transparently for the process transfer it to another physical hardware, so the process doesn't notice the difference. It's not that easy, but they've managed to do it, and it works rather well, I would say. In 2006, OpenVZ also rebased to RHEL 4 kernel. The reason I'm saying that is that they've been trying to keep up with the upstream development of Linux, and they've been trying to port OpenVZ patch to like every new release, but they found out that there's so much overhead with that associated that they just couldn't keep up. And they decided to refocus and build their technology on top of Red Hat kernels. What Red Hat basically does is that every couple of years they take a snapshot of a vanilla kernel, they fork it, and then they maintain it for a really long time without the ABI changing in the code. So the OpenVZ project has much less work with keeping up with upstream, and they can focus on the features themselves. In 2007, most of the commercial competition to Linux caught up with containers. IBM introduced workload partitions. HP introduced something similar to their HPUX system. OpenVZ rebased to RHEL 5 kernel and also did what was like last from the ports to upstream kernel. They ported that to 2620. And important thing to note, in 2007, C groups mechanism was merged in the upstream kernel. C groups were unlike the other technologies developed by Google and IBM guys. In 2008, OpenVZ namespaces upstreaming process basically began. The OpenVZ guys, those crazy Russians, re-implemented all of the namespaces isolations they had in their OpenVZ kernel. They created in a way that Linux community could process, and they posted it up for reviews. And by now, all of these namespaces are in upstream kernel. So this was the moment when we were first able to run containers with the upstream kernel. Also in 2008, LXC tool set appeared on the scene. It's developed by Canonical. So that makes that project fairly Ubuntu-centric. But it was able to run what I would call OS-level containers as early as in 2008. Now, in 2010, OpenVZ rebases to more recent RHEL 6 kernel. The development continues on top of RHEL 6 kernel to this day. They added a feature which is called vswap. That drastically reduced the complexity of user bean counters. Previously, when you wanted to set the limits for the container using bean counters, you basically had to read the whole book about bean counters, and from that moment when vswap was merged in, it's only just two parameters. You only set RAM and swap for the container and you're good to go. And they added a nice feature called ploop that basically does something similar to hypervisor virtualization, that you have a container in a single file as you would have a VM in a single file. And they didn't kind of stop there. They also tweaked the implementation so they could track changed blocks during live migration, for example. So the live migration feature got even faster. Now you can migrate containers with like 2 seconds of downtime. So even TCP connections hold up and everything works as expected when restoring on the remote node. P-loop also allows you to do instant snapshotting, which simplifies backups. It can online resize, compact, and merge those snapshots. And it has the right tracker for live migration. In 2011, project CREU was proposed. CREU stands for checkpoint and resume in user space, which is the reiteration on the idea of live migration of processes. They tried to merge their live migration stuff in upstream kernel before doing this, but that was mostly kernel-based work. It touched like every possible subsystem in the kernel, and the upstream developers don't really like that when they get a huge patch, which is like impossible for reviews for anyone. So they decided to work around that and do most of the work from the user space. They would only need to get some debug information from the kernel when doing the checkpoint phase. So they get information from /proc, and there have been some missing information which they added for use in CREU project, but it appears it's also useful for other tools like SS, which is similar to netstat. SS uses facilities which were developed for CREU project. So with CREU today you can checkpoint and restore most of the processes you run on your laptop. For example, if you have a browser running, you can checkpoint it, which will create the dump files. Then you transfer the dump files over to another machine with the same kernel, and you can restore your browsing session there, and the browser doesn't notice the difference. Also important, even for the world of containers in Linux, was LinuxCon in Prague that same year, where all of the important guys from the development process came together and decided there will be only one container technology in upstream kernel, so that we don't get the same situation we have with hypervisors. In Linux kernel today, there are two competing hypervisor technologies which basically do the same stuff, but they share almost none of the code. And those are Zen and KVM. So, in 2012, CREU 0.1 was released. That was like a first snapshot of the work you could really use. It wasn't able to do much by then, but it gave developers the idea how to do checkpoint and restore in user space. VZCTL 4.0 was released. That's the user space component for controlling the containers. So now you can use it even on upstream kernel. You don't have to have OpenVZ patched kernel to run VZCTL. So you can manipulate in-kernel container technologies to create really easy to use operating system level containers. In 2013, Docker appears. Google releases Let Me Contain That For You project. Anyone hoping to use that, I wouldn't invest that much time in it, because Google announced that they would be switching to Docker. CoreOS was released, and VZCTL adds an interesting feature which allows you to IO limit the containers. That wasn't possible before. And user namespace was merged in vanilla kernel. Before user namespace, when you had a root in a container, it was also root on a physical node. So if you send a reboot command to a container, it would reboot the whole physical host. With user namespace, the root in the container is nobody outside of the container. So it doesn't have privileges to manipulate the hardware anymore. But Docker to this very day doesn't use user namespaces. In 2014, VZCTL 4.8 was released, which integrated the p-loop write tracker feature and enabled for faster live migration. Really, now you can live migrate almost any running application in OpenVZ container and have like 1 or 2 seconds of downtime, which is the time which it takes to copy the last modified blocks of the data in the memory and on disk. And Parallels announced they would be merging Parallels Cloud Server, which is another name for Virtuoso, and OpenVZ Codebase into single shared open source project. What they did up to this point, they basically had just one technology in kernel, which was OpenVZ, but they had 2 separate sets of user space tools. One was VZCTL and the other was Virtuoso, or the PCS stuff. And now they will merge it, so we can expect some more innovation from them. This year, OpenVZ announced that they are releasing RHEL 7 based kernel in beta version. It will use Creo for live migration instead of their homebrew patch. C groups will be replacing user bean counters for good. And you can use it today, but VZCTL tools are not compatible yet. The work is underway. I'm expecting they will release that sometime during late summer, I would guess. There's a public Git repo you can check out to have a feel what the container technology means for kernel and what the changes are. So, OpenVZ and Docker. There are multiple ways how OpenVZ relates to Docker. You can use Docker inside of the OpenVZ container, so you can basically run container in a container, where on the first level you would have OpenVZ. You would create a full OS level container, and then inside you would run Docker, and there the Docker containers. You can use Docker outside of the OpenVZ stuff. That means you would basically, instead of upstream containers, you would create OpenVZ containers and run your Docker images in OpenVZ. Important thing to say, OpenVZ containers are much more secure and better isolated than upstream containers today. So if you want to see more details, there's a pull request open on GitHub to make Docker work with OpenVZ containers, and it should be merged upstream fairly soon, at least judging from the comments.
How many look good to me does it have?
Sorry?
How many looks good to me does it have?
There was like just one minor issue to sort out, and they are really.
Other than that looks good to me.
Yeah. And how about Docker and Creo? Creo capabilities were merged in libcontainer like 3 days ago. So you will be able to live migrate your running Docker instances to another physical hardware without the Docker instances noticing anything.
Can you also counter and restore that offline?
Yep. Well, there are two basic use cases for live migration. One is when you're rebooting the physical hardware so that the container don't notice the reboot itself. And the other use case is the obvious one, to migrate the stuff to another hardware. So how about containers in vanilla kernel? Containers in kernel are basically, it's not a single technology, it's a set of multiple technologies, and you can combine them in really interesting ways to create different level of containers according to your application, according to your needs. So any combination of C groups and namespaces creates a container, and you do that by spawning a process in pre-created namespaces and C groups. So when you put init process in different namespaces and some C groups, you have a container which is operating system level container, because the init will spawn all the processes there. When you put just a single application in namespaces and C groups, you have an application level container. That's what Docker does. And also you can apply only a few of those namespaces. Let's say you need to just separate the application on a network level, so you put it in different net namespaces, which creates different devices in the containers, different routing tables and all that, but they share everything else, so they see process IDs and all that. It really depends, and it's flexible. So I would encourage you to explore the technologies more beyond what Docker provides. So what can you use to manage containers in current state of the art? It's LXC. Docker to this very day uses LXC to run containers. Then there's LXD, which is a daemon to manage LXC. That's all really Ubuntu-centric stuff, so it's somewhat harder to run it, for example, on Fedora. Then there's Docker, obviously. libvirt LXC was announced to be deprecated, so I wouldn't be using that, but it's there. Systemd nspawn is the way to spawn containers with systemd. Then there's vzctl, which is ready to use and fairly stable. Let me contain that for you. And then there is libct, which is from Pavel's guys. It's a C library to manipulate processes and all those namespaces and C groups. So you can create your own containers how you like, and you can manage the whole lifetime of the container with just libct calls. So how does all that come together when it comes to Docker? Currently, in the default setting, if you install Docker, you're using LXC driver to create the containers. But there's an initiative to move everything on top of another layer of abstraction, basically, which is libcontainer. That is written in Go, so I don't give it much hope to be that widespread, but that's their problem. And libcontainer in the end uses libct, which enables you to use either upstream container technologies or OpenVZ.
I think that they switched already to libcontainer by default.
Oh, okay, it's possible, yeah.
I think it was like March or
okay.
Yeah, something like that.
Okay, so they're using libcontainer now, but
it's using libcontainer by default now.
Yep.
So
Which version?
I think it was in 0.9 or something like that in March.
Well, 1.0 should be using libcontainer.
Yeah, but they were switching. Yeah.
Yep. Yeah, the process wasn't exactly smooth. So the conclusions to take from this talk are that containers aren't the same thing as Docker. Docker is a single, very limited way of using container technologies to deploy your applications. It often takes the reinvent the wheel approach. For example, with PID #1, this is my favorite. By default, Docker allows you to run a single process by the end of the process of the container creation. So for example, you would run, let's say, PHP FPM. But what if you need to run SSH, for example, to have an overview how the FPM is working? Well, then you use something which they call supervisor D, and that enables you to spawn multiple processes in the container, and that basically is the same thing as init. So they are reinventing the wheel in many ways. What I'm trying to say is, when you're all hyped up and want to deploy containers, just take a step back and think a bit about what you're actually trying to accomplish. By far, the most mature container technology you can get now for Linux is OpenVZ. The minor downside is that it's not upstream, so you need to use RHEL 6 kernel today. But that kernel enables you to run basically every possible set of user space utilities you can think of today. So you can boot up even the most recent Ubuntu on RHEL 6 patched OpenVZ kernel. So you don't have to worry about, oh, that kernel is so old, oh my god. That's what I hear all the time, but it's not really important to just look at the kernel version. It looks like really old. It's 2.6.32 dash something, but it has so many backports from current kernels that it's not really that old kernel now. And the question I'm gonna leave you with today is, do you actually want Docker or containers? I'm sorry, I'm not going to be here for the after party, so if you have any questions, either ask now or feel free to send me an email anytime you want.
Just think, for example, if I use OpenVZ, does provide some mechanisms like Dockerfile, like easy rebuilding of images, for example, patching, stuff like Docker registry. And
by default, OpenVZ provides you templates of the basic distributions, so you get like CentOS template, and you can write your own scripts which will unpack the template, do some stuff there, and run whatever you need in rc.local or whatever, and pack that again, and you have your new template which you will use for creating containers.
okay.
It doesn't force you to do what you just said, but you can do that with OpenVZ.
For example, the main benefit of Docker for me is that, for example, I have some JBoss container and and I am using it as a basic image, and I'm deploying it to all my infrastructure. And there is now CVE which and I need to patch it. So in Docker I will just rebuild image from Dockerfile and let Docker or Kubernetes to redeploy it.
You could do that with OpenVZ as well.
Yeah.
You would just redeploy the container. That's easy thing to do. It's just you basically delete the directory and unpack the image again. If you want to go outside the OpenVZ tools.
It doesn't have the layering advantage, right?
Yeah, it doesn't have that. But it's not really an advantage. There's been some survey like 5 days ago that one third of the images is infected or susceptible to some vulnerabilities because those pre-created templates are not updated frequently enough.
Yeah.
Any more questions?
How secure it is if you get access to the OpenVZ container inside, for example, you will SSH inside, can you get outside of it?
That's a very good question. Of course, there are like many more vectors from where the attacker could attack the system. There's like 100 and something syscalls which the attacker could use to exploit the kernel. But most likely, and due how all those mechanisms work, the attacker would be only able to obtain root on the container, not the physical hardware. But there is many more ways to obtain root on the physical hardware than with hypervisors, obviously. So it's in a sense it is less secure, but provided there are no bugs in the code, it is about as secure as hypervisors.
I think the correct answer to that is that you should get a VTS3 and try to escape.
Yeah, I would advise you to do that.
Maybe there's some Linux support for Obtížně?
No, not yet. The official rationale is that SE Linux is basically a method for separation of processes, and so is OpenVZ. So if you need to separate out multiple services, their advice is to create that many more containers. But I'm trying to kick those guys to implement Linux in every chance I get. So I'm hoping they will do that someday.
So you mentioned Chorus, but you skipped Rocket and after there.
Yeah, well, Rocket is basically using the same kernel technologies, and I was talking from like the kernel perspective. But yes, Docker and also CoreOS Rocket mechanism are the same way to deploy application containers. It's like really similar, but it just can't be one single product because they are two separate companies and they have different investors. So if that's it, thank you very much.
Thank you for making me feeling dumb for doing the Docker feature. But once we now we have the technical break, like 5-10 minutes. And the questioner guys, like come to me. I have a nice t-shirt, so you feel them like me.
Is there a keyboard here or?